for today, our key focus is about a topic that has something to do with floating. It is the law of buoyancy, the Archimedes principle. So we will be unlocking 3 E's: explanation, examples, experiment. So what are you waiting for? Let us all start. This is the first E, explanation. We do have here the picture of Archimedes. He is the Greek mathematician in the 3rd century. He's the one who discovered the buoyancy, and the buoyancy is the ability of the fluid to support the object to remain afloat. We do have here also the buoyant force. It is the thrust force or the supporting force that helps the object to float. So if the buoyant force of the fluid is equal to the weight of the object, then it will float. But if not, then it will sink. Also, we do have here our formula. And our formula is F sub B is equal to P times G times V, where F sub B represents the buoyant force, P for density, G for acceleration due to gravity, and then V for volume. This is the formula that we will be using whenever we encounter a problem that is related with buoyancy.
So for our second E, example, I have here my prepared problem and solutions. So this is the problem. What is the thrust force of a magic ball that has the radius of 4 cm and gets immersed in the water? So the question is about the thrust force or the buoyant force. So this is the formula that we will use, the Archimedes formula. F sub B equals P times G times V. So our standard density or P is equal to 1,000 kg per meter cube. And our gravity is equal to 9.8 meter per second square. But our volume here is missing. So for us to find that, we're going to use the formula V equals 4 over 3 pi r raised to 3. So we have here our radius of 4 cm and convert it to meter, which is 0.04 meters. Then through substituting, or by substituting, we will get the answer 2.6 times 10 raised to negative 4 m raised to 3. Then substitute it to the real formula. F sub B equals P times G times P. 1,000 times 9.8 times 2.6 times 10 raised to negative 4. Our buoyant force or our thrust force is 2.55 newtons.
For the third E experiment, titled Top or Bottom Buoyancy, I will just put the objects on the water and let's see if which one will float on the top and sink at the bottom. And peeled orange goes up and peeled orange goes down. Second part, I put some salt on the water to have a solution and see the conditions if it's just water only and water with salt. On the water, it sinks at the bottom. While on water and salt solution, it floats on the top. Thank you.